Okay, where am I? Solve with substitution, 1C. Okay. In the real world, guys, it doesn't matter. If you find a system of equations lying out there and you want to solve it, it doesn't matter what method you use. You've got substitution elimination right now. I'm going to teach you a couple more ways. Any of them are fine, except these directions specifically say use substitution. So what does that mean I need to do?
Plug in. X equal to 6
Get
plus
a
6.
letter by itself, and it makes sense to get that one by itself since it's already erased by itself. And then I'll plug that in right here. So negative 2, 6 plus 3y, plus 6y equals 4. Everybody still with me? Substituting or plugging in. All right, so negative 12 minus 6y plus 6y.
No solution. Or no something.
Whoa. Does negative 12 ever equal 4? No. Well, yeah, honestly, in my experience, once in a while, somebody will say something like that. But no, negative 12 doesn't equal 4. What am I supposed to be doing? Solving the system. My answer is supposed to be an ordered pair, right? My answer is supposed to be where these two lines cross each other. So guess what? They don't cross each other, which means what about these two lines? They're parallel. These are parallel lines. They don't intersect. They're parallel. If you graphed them, you would see parallel lines. All right, next. Again, we're substituting, so what do you think we might do here?
Get X by itself.
Actually, I already have y by itself, so can't I just like set these two things equal to each other? I could also get x by itself, but that's gonna be like more work.
I like more.
Okay, go for it. So I'm just gonna set them equal to each other since they're already equal to y. Now, what do I do now?
You gotta get them all on one side.
Get them all on one side because this is gonna be a quadratic equation. So I'm gonna add the x squared over to here. I'm gonna subtract the 2x. And I'm gonna subtract the 1. So I think that's what I end up with if I move everything over to the right. That look okay to everybody? What do I do now? Factor. GCF. And what does that tell me then about x? X is either gonna equal 0 or x is gonna equal 3. But remember, you're looking for where these curves intersect each other. So your answer needs to be ordered pairs. Would you guys quit kicking my
I'm sorry, I'm
boxes
really sorry.
around?
I actually don't.
So x is 0 or x is 3. And then we'll just plug those back in. And I like to plug them in right here, the easiest. So if I plug in 0, I get 1. And if I plug in 3, I get negative 2. I think we talked about this yesterday, but does it make sense to you that there could be two answers and 2 different points to this? Yeah, because this is a line, but that is a parabola, and they can cross and do cross in 2 places. Perfect. All right, 2A, elimination. How does that work? The problems look exactly the same, but now it says elimination. So 2x. How does this work? What do we do if we're going to eliminate? I've got to add my equations together and eliminate one of the variables. So Abe says if I multiply the top equation by 2, that's going to give me 4x plus 2y equals 20. And when I add my two equations, do you see how the y's are eliminated? Now, he didn't have to eliminate the y's, he could have eliminated the x's. He just felt like it was easy to eliminate the y's, so that's what he did. So 5x equals 15, and x equals 3. And then just like before, the same kind of problem, the answer's in ordered pair. So you're gonna have to go back and somewhere plug in 3. It doesn't matter, just pick a place and plug it in. So 3 minus 2y equals negative 5. Negative 2y equals negative 8. Did you get y equals 4? So the answer is 3, 4. Tell me that's ringing some bells from back, way back when you were just a youngster. All right, anybody, this is the same exact thing. Now this is gonna be a little bit tougher because I don't think you're gonna be able to eliminate without multiplying both equations by something. Does anybody feel comfortable enough to come up and do this? It is on video, so just FYI. Anybody feel comfortable enough to come up and do it?
I got it.
Jake, you're wonderful, thank you. Now, you should be doing it on your paper, huh?
Multiply like this.
Yeah, absolutely. So he's gonna multiply the top equation by something, and then he's gonna multiply the bottom equation by something else. And hopefully he's gonna make things match, so they will cancel out when he
What's
adds.
that? 80, 92? Yeah.
Yeah. Oh, shoot, is this lunch period?
Yeah.
Okay.
Doesn't matter where you plug that.
He got negative 2, 3. How do the rest of you feel about that? Everybody got that? Do keep in mind that these problems are really easy to check. So for example, his bottom equation is 3x plus 4y equals 6. So he says x is negative 2 and y is 3. So if I plug negative 2 and 3 in, it should work out, right? And it does. So those are really easy to check if you want to do that. Thank you. That's perfect. All right, a couple more and then we'll be done with this section and we can move on to the new stuff. All right, so here we go. 2x minus y equals 3, negative 4x plus 2y equals negative 6. Okay, if we're going to eliminate maybe top row times 2. This one says 0 equals 0.
All real numbers.
It's not a thing. It is a thing, but not a thing for this. Here's what I need for you to understand. Put this in the context. This is a line, and this is a line, right? The answer, the intersection of two lines is going to be points. Not every point in the whole wide world. Which points are the answer to this question? The ones that are on the line. So when we write our answer, we say, okay, it's gonna be a set, a whole set of numbers, a whole bunch of them, infinitely many. They're gonna be points. Such that, that's just a set symbol for such that. So all the points such that 2x minus y equals 3. What that means is that you have infinitely many answers. Not all numbers, but every point, every ordered pair that's on this line is also on this line. Would you agree with me?
You're saying like there are two lines stacked on top of each
Yep,
other?
they're right on top of each other. So if you did this one in blue and this one in red, you'd have a purple line because they're right on top of each other. Okay? All right. One more. By the way, this is different than what happened before. Remember before we got, I can't remember what it was, but it wasn't true. This is true. Okay, 2x plus 2y equals 100. And xy equals 300. Okay, kids, this is a new problem. This is number 3, and all it says is solve. So it doesn't tell you how to solve it. It just says solve. So what are your thoughts? Do you think this problem lends itself to substitution or to elimination? What do you think? Substitution. I think substitution because I can't really eliminate anything because I don't have x's and y's separate in this bottom one. Yeah. So, how do you want to substitute?
X is equal to 300 over y.
So x equals 300 over y. I can live with that. And then that is going to go in here. So 2 times 300 over y plus 2y equals 100. Now remember guys, this is 2 over 1. Don't be silly. This is 600 over y plus 2y equals 100. What in the world are you going to do with that?
Bet you you'll tell me.
I will, but I'd rather you took a stab at it. What do we always do when we got a fraction sitting in the middle of an equation? Get rid of it. So we'll multiply everything by y. So we have 600 plus 2y squared equals 100y. So we're just multiplying everything by y. So we don't have that fraction anymore. What do we have now?
Quadratic.
Now we have a quadratic, so we always get our quadratics equal to 0. And I probably could have done this at the beginning, but do you see how everything here is divisible by 2?
Yes.
It might just make it work a little easier if we did divide everything by 2. Now what? Yeah, if it factors, absolutely go ahead and factor it. I'm not seeing any factoring. I could mess with it a little bit and try to figure it out, or I could just not waste time and jump in and do my formula,
Quadratic.
which is negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a. Does that look okay to everybody?
Yeah.
All right. Peter, you got my calculator, so I'm going to rely on you now to type this in. So there are going to be 2 answers. One of them we're going to do the plus, and one of them we're going to do the minus. So you're going to get 2 y's, which means I'm going to have 2 answers here.
Pressure's immense.
Okay, so everybody should be typing. Meg, are you typing? let's not be a spectator, let's be a
The
participant.
plus is 93.58.
93.58. Do I have any kind of agreement with that? That one of the answers? Drew, it is? Okay.
Thank you, Drew.
Yeah.
I don't think that's right.
I got 43.02. That's for plus. What did I get?
So it's not this. That's too big a number.
Yeah, I
What did you
redid it.
say, 40?
43.03.
Okay. And then what was the other one? Probably 6.97. Oh, these are Y's.
Yeah, I got 6.97.
43.03 and 6.97 are our two Y's. All right, take 300 and divide it by 6.97, and what happens?
43.04.
And 300 divided by 43.03 is probably 6.97, or close to it. Was this 03 or 04? That was 03, and this one came out to be 04. Little round off there in there, I guess. Is that okay with everybody?
Yep.
Two answers, that's a line. This is what we call a hyperbola. It looks like this, kind of like a reciprocal function. So when you draw your line in there, of course you're going to get 2 points of intersection. All right, well that timing worked out perfectly. We will come back at 48. Back in your seats at 48. 4-8. Go to the back room. Get your business taken care of. Be in your seat at 48.